Hello everyone, I am Kushal and today's subject is satellite and communication, and today we're gonna discuss about multiple access techniques. Let us move on to the contents. What are all the discussion are the topics of today's session? And FDM, frequency division multiple access, TDM, CDMA, OFDMA, SDMA, and applications of multiple axis techniques, advantages and disadvantages of multiple axis techniques, and further trends in the multiple axis techniques. These are all the topics which we have discussed in the today's session. Let us move on to the first, a comprehensive overview. That means introduction about this topic. And multiple axis techniques, a comprehensive overview. Well, these presentations explore the various multiple axis techniques maps using in a wireless communication. We will delve into the characteristics, application, and advantages, paving the way for a deeper understanding of how these techniques enable efficient and reliable data transmission. Let us move on to the second topic, FDMA, frequency division multiplexing axis, how it's work. FDMA divisions the availability bandwidth into non-overlapping frequency channels, allowing multiple users to transmit simulative without inference with each other. Applications commonly used in a cellular network, satellite communication, and cable televisions technique. Then TDMA. TDMA means time division multiple axis. How it's work? The time division multiple axis divides the available times into slots, allocating each slots to a different users. Users take turns transmitting their data, avoiding simultaneous transmissions. Applications utilized in a mobile phone networks, satellite communication, and a wireless local area networks. And let us move on to the CDMA. CDMA and means code division multiplexing axis. How it works? Code division multiplexing axis assigns a unique code to each user, allowing multiple users to share the same frequency bandwidth. Simulation simultaneously, the code enables the receives to suppress and the decode the desired signals. These are the applications widely used in the cellular networks such as GSM and the CDMA 2000 and the satellite communications. And let us move on to the orthogonal frequency division multiplexing axis. The orthogonal frequency division multiplexing axis works divides in the availability bandwidth into a multiple orthogonal subcarriers, each assigned to a different user, allowing for efficient and flexible data transmission. Then what are the advantages or what are the applications of OFDMA? Means commonly used in a 4G Lite and the 5G mobile networks, as well as Wi-Fi and digital video broadcasting systems. Then move on to the space division multiplexing accesses, that is nothing but SDMA. SDMA, how its work means SDMA utilizes the physical location of a user to separate and transmit data. Each user is assigned a specific sector as a beam, allowing for simultaneously transmits within the frequency band. And the applications of SDMA of often used to conjugate with other MATs, particularly in the cellular networks, to improve coverage and capacities. Let us move on to the applications of the multiple axis techniques. Cellular networks MATs are essential for enabling voice and data communication between phones, mobiles, and the base stations. Wi-Fi networks MATs allow the multiple devices to connect to a signal Wi-Fi router, simultaneously sharing the availability bandwidth. And in the last point, satellite communication. MAT facility communication with the satellites, enabling service such as a broadcasting, internet access, and the navigations. Then let us move on to the advantages and disadvantages of multiple access techniques. And we are discussing first advantages, and there are few points of advantages are there. We are discussing a few points from advantages and disadvantages. And in advantages, increased capacity and efficiency, and improvement spectrum utilization, enhanced data security and reliability, And let us discuss the disadvantages of the multiple access techniques and complexity to implementation, potential for infrastructure, limited range and coverage in some cases. And let us move on to the future trends, further trends in the multiple access techniques, and that is 5G and behind, network slicing, tailoring network resource to specific applications and requirements, non-terrestrial network, utilizing satellites and the high altitude platforms to expand coverages, and AI means artificial intelligence, optimizing network performance and the resource allocations. These are the topics which I would discuss in the multiple access techniques. Thank you.